Today, we shall study about digital electronics and logic gates in semiconductor electronics of modern physics chapter. In electronics like amplifiers, oscillators, the signal, current or voltage has been in the form of continuous time-varying voltage or current. Such signals are called continuous or analog signals. Analog signal and digital signal are shown in the figure 1a and b. A typical analog signal is shown in figure 1a. Figure 1b shows a pulse waveform in which only discrete values of voltages are possible. It is convenient to use binary numbers to represent such signals. A binary number has two digits, 0, say 0 volt, and 1, say 5 volt. In digital electronics, we use only these two levels of voltage. As shown in figure 1b, such signals are called digital signals. In digital circuit, only two values represented by 0 or 1 of the input and output voltage are permissible. We shall study the basic building blocks of the digital electronics called logic gates, which process the digital signals in a specific manner. Logic gates are used in calculators, digital watches, computers, robots, industrial control systems, telecommunication, etc. A light switch in our house can be used as an example of a digital circuit. The light is either on or off, depending on switch the position. When the light is on, the output value is 1. When the light is off, the output value is 1 or 0. The input are the position of the light switch. The switch is placed either in the on or off position to activate the light. Logic gates. A gate is a digital circuit that follows current logical relationship between the input and output voltage. Therefore, they are generally known as logic gates because they control the flow of information. The 5 common logic gates used are NOT, AND, OR, NAND, and NOR. Each logic gate is indicated by a symbol and its function is defined by a truth table that shows all the possible input logic level combinations with their respective output logic levels. Truth tables help understand the behavior of logic gates. These logic gates can be realized using semiconductor devices. First, NOR gate. NOT gate. The logic symbol and truth table is shown in figure 1a, A and B. This is the most basic gate with one input and one output. It produces a 1 output if the input is 0 and vice versa. That is, it produces an inverted version of the input at its output. This is why it is also known as inverter. The commonly used symbol together with the truth table for this gate is given in figure 1a. Second, OR gate. The logic symbol and truth table is shown in figure 1a and b. An OR gate has 2 or more inputs with one output. The logic symbol and truth table are shown in figure 1. The output is 1 when either input or input B or A or B or both are that is, if any of the input is high, the output is high. This gate can be used for modifying the pulse waveform also. Third, AND gate. AND gate has 2 or more inputs and one output. The output by of AND gate is only 1 when input A and B are both 1. The logic is symbol and truth table for this gate are shown in figure 1a and b. Now the NAND gate. This is an gate followed by a NOT gate. If inputs of A and B are both 1, the output Y is not 1. the gate gets its name from this note and behavior. NAND gates are also called universal gates, since by using these gates we can realize the other basic gates like OR and NOT gate. Now the NOR gate. Logic sample and tech table are shown. It has two or more inputs and one output. A NOT operation applied after OR gate gives a NOT OR gate or simply NOR gate. Its output is 1 only when both inputs A and B are 0. It means neither one input nor other input is 1. NOR gates are considered as universal gates because we can obtain all the gates like AND or NOT by using only NOR gates.